Let's talk about the last part in option C, which is about MRI. In the picture, you can see there are two kind of machine. They look quite similar. In fact, one of them is MRI, and the other one is the one that we mentioned before, called the CT scan. So I think you don't have to really distinguish two of them. I mean, by the appearance, but more about how they work. So let's firstly quickly take a look of the study guide and take a look of what you need to know first, right? Because if you really want to understand fully, you actually need to study 3 years, 4 years of bachelor undergraduate program in order to understand that, because that is a huge amount of knowledge. So in what we have to know, I think we are learning the basic of how it works. In fact, the word magnetic resonance imaging, MRI, is simply using a physical phenomena called magnetic resonance, I should say nuclear magnetic resonance. And in fact, in the past, people call that machine as nuclear magnetic resonance instead, and it wasn't get very popular because people, when they find the word nuclear, they thought it is something that is very dangerous, and in fact it is not dangerous. It's even safer than CT scan. And that's why later on, when the name was officially changed to magnetic resonance imaging, it was much better, and in fact nothing got changed, right? Interestingly. Anyway, so what you actually need to know in detail is something called the gradient field in magnetic resonance imaging, and also something called the relaxation of the proton, and something called spin, and that spin would help to emit some sort of a radio wave later on. And lastly, we have to compare the ultrasound and the MRI, actually X-ray also, actually all three kind of the method. Okay, so as usual, we may want to read the textbook, but really this time what I do is I spend some time to read the textbook, and I find it's really quite worthless because it's really not well written. I mean, if you want, you can try to read them, and I would rather you try to follow my way, okay, which is I'll show you 1 or 2 videos which I want you to watch, and then I will go through some paragraphs in the cognitive. Okay, so if you really want to go ahead, you may want to pause the video first and take a look of your textbook. Okay, so right now I showed you the best video I find on YouTube. Okay, there are actually quite a few of video, and I find this one is really the best. So I'll put the link in the description. Basically, it tells you the basic idea of how MRI works is by using the idea of spin. Spin, if you try to read the textbook, which probably you didn't, is one of the property. If you remember, when we were learning about chapter 7, we talk about charges, lepton number, baryon number. Spin is more like one of the other properties that we haven't learned. All right, in the past, if you try to read some past paper before 2016, before that, spin was one of the property of particles in particle physics. And now it's been out of syllabus already. But anyway, all right. So it's something to do with is when the proton, because it carry charge, when it spin, it can actually produce a magnetic field. So this video is actually very nice, showing you what it means by parallel and anti-parallel, and how the radio wave got emitted and received. And just make sure you go through this video. Okay, you may want to pause the video and find the link in the description. The second video I want to show you is again, I'll put the link in the description, and this video is more about showing you the actual thing, even though we can't show you, of course, unless I take you to a field trip somewhere in Hong Kong. To be honest, I never took that before, so I don't think anyone took it before as well, so it might not be familiar like to any one of us. but I think seeing the real thing through the video at least can help you to understand more. So this one is a very interesting experiment that they put the pineapple inside the machine, so you can see how it looks like really by different layers. Alright, it's actually quite quick also. And then they talk about how much magnetic field it will be produced and how it's made. And some interesting thing is one thing about magnetic like MRI is you cannot bring anything that is magnetic in it. That means including any kind of metal. So they actually perform an experiment, you may say, which the chair or anything will simply get stuck, or if someone like this one throw anything inside, alright, it will be a disaster simply. Okay, so you may want to take a look of this video and firstly pause the video, and you can find the link in the description. Okay, so for now, as I said, I'll prefer reading the cognitive. So I will want you to take some time to read it first, and basically the whole thing about MRI and also the comparison here. The table is actually quite nice. So pause the video, try to find out the keywords, and I'll get back to you. Okay, so let's take a look here. The basic idea or the basic information about MRI compared to CT scan is it will provide much higher resolution. If you try to look at the photos in anywhere online, things like these, definitely you cannot do it with X-ray or CT scan, because if you remember, they can only do a big contrast between bones and the soft tissue, but then you can see even the eyeball can be seen quite clearly. Okay. However, of course, the drawback is it is much more expensive. Otherwise, if this is cheap and better, then no one would use X-ray anymore for sure. And therefore, only when you use it when you want to detect maybe tumors or brain issue, then you use it. But for maybe bone fracture, you use X-ray still. Here, there's a really nice diagram which I really like to see, even though it may not tell you anything that is helpful in the exam, but it helps you to visualize what actually happened. So inside the machine, there are actually a few rings, including magnets, and also something called the gradient coil, which help us to locate the position. Later on we'll talk about it. And something called the radio frequency, which you should have already known from the video already. And this is to detect it like different part of the body with different density. And this is a basic mechanism of the nuclear magnetic resonance, including like what you could find in the video as well. It was more about absorbing and re-emitting the electromagnetic radiation, which is actually the radio wave. And because of our body contain about 70% of water, and inside there are hydrogen atom, and therefore we take advantage of that. When we try to align the strong magnetic field, it will be either parallel or anti-parallel orientation for the spin. The spin is actually either, you can imagine, either up or down. And so if we say up is parallel, then down is anti-parallel. So basically opposite direction. I don't know why they call it anti-parallel instead of up and down, but then I guess that's the idea, because originally at the beginning when I first see this and learn about this, I was thinking if parallel is like this, then anti-parallel shouldn't it be more like perpendicular? But that is not the case. Okay, so it's just some tiny detail here. One thing it mentioned here is called precession, and precession is something similar to the spinning top. All right, spinning top where people play it, for fun simply. But in fact, this precession, this motion is actually quite important, not only in MRI but also in terms of astronomy. In fact, our planets also have precession also. All right, and that's why the orbit actually has been changing slowly over the long time. And back to here, something called resonance, which of course are more fundamental idea about how resonance could happen, is something to do with the so-called natural frequency. The object is absorbing the energy if the frequency given is matching its natural frequency. We in fact talk about it when we were in I think simple harmonic motion, and probably in particle physics also. One very famous example is breaking the glass simply. So you could actually somehow use a certain pitch and break the wine glass. Furthermore, we would have the top spin, and like again like what is mentioned in the video, but here is more like the keywords here. When they change the state from maybe upspin to downspin, then they would go for a lower energy state, and when you go for lower energy state, of course energy is conserved. So where does the energy go is by emitting the photon, and the photon with the frequency of radio waves, so that's why it's emitting radio waves simply, which can be detected by the radio frequency coil. You can imagine the radio frequency coil is exactly the same as what is inside the old traditional typical radio. Inside there actually simply electrical wire as a coil, and they could be able to pick up, and something that like what I said earlier is called inductor or inductance, inductor with the inductance, and they can pick up a certain frequency in that case. And by the time when they try to emit that photon, there is something called relaxation time, and it would depends on the tissue. If it is bone, it will be a certain time. If it is fat, it will be another time. So in that case, then using this technology, we'll be able to distinguish what kind of material or medium it is. Okay, different from the ultrasound. You may try to see the thickness, but here you can even know they are exactly different kind of intensity or different kind of density also. To make the 3D model by different layers, then we have to use something called the gradient field, which if you recall what we have here, the so-called magnet is a static, I think it's here, yeah, it's mentioned, it's a static strong primary uniform magnetic field. So that means, and that's why in the video you see even it's not switched on, then this is always here. So you are not supposed to bring anything, your credit card, your cell phone, your watch, anything, all right, in it. Otherwise, you will simply get sucked into this magnetic hole. And the gradient coil is simply another coil. You can simply run the current through it and then induce the magnetic field. And the most important thing is using this magnetic field, then you can locate different parts, because your body will simply at different position, you experience different strength of magnetic field, and in that case the radio wave frequency will be different if it can match or not. So you can all find the keywords here. Okay, and that is actually pretty much it. All right, I know it's probably a bit hard to visualize. I hope the video, all right, here these two can actually help you. If you find any other better video, maybe you can share with us. And lastly, this is a comparison between all three of them. Okay, so the basic idea is, first of all, very distinct differences. X-ray, they certainly is ionizing radiation like gamma ray, alright, it's ionizing, or alpha or beta radiation. So you cannot take too many. And X-ray in itself is 2D, but if you could take it as a CT scan, then it will become 3D. Alright, so this may not be a very strong reason, but I think it's mainly ionizing radiation. And you can't do imaging if the whole thing is, I mean the photo you want to take is full of soft tissue, right? I mean you can distinguish bone and soft tissue easy, but if something that you only contain soft tissue like your brain with a tumor, let's say, unluckily, then you can't use X-ray directly. It's relatively cheap compared to others and with a good resolution. For ultrasound, there's no ionizing issue, but then the worst thing is that the resolution is the worst, basically, in this case. And yeah, it's no harm in radiation. You could do 3D, but usually 2D is real time. Okay. Oh yeah, one thing that you can't do is if, let's say, your organ contain air, for example your lungs. If you remember the reflection of ultrasound between the air to skin, then most of them will get reflected. So basically the sound wave, the ultrasound wave, will simply be stopped and all get reflected by that time. So you can't use ultrasound for things like lung or like maybe even your stomach or intestine. For MRI, I think we just mentioned, is more expensive with high resolution. There's no radiation at all. So far there's no research saying that it is harming any health, but that it will take a long time. Even CT scan, if you remember, it take a few seconds, like 10 seconds, while this one may take a minute or even 1 hour for body, depending on the size, of course. And therefore, if someone is afraid of the dark, you can't stay in the dark for too long time, then probably is not suitable for you. Or anyone who got metal implanted inside the body, like someone have something called a pacemaker, their heart has some issue and they use some sort of machine to help them to pump, then of course it will be an issue. Okay, and pretty much it. Okay, so right now I will want you to pause the video. There isn't many questions we can find, but here is one example from the past paper. So try it out, pause the video first. Okay, so I'll simply show you the marking scheme, and you can see this video, I mean not video, but this question is simply asking you the basic mechanism. There is no calculation, of course, involved. And the first question is asking you the effects of the radio frequency signal on the proton of the body. So basically it would help the proton to change the spin, if you remember, and therefore when it changes spin, then the energy state would change. So originally maybe it was anti-parallel, if you remember, downwards anti-parallel, and then if it change to upward, like in the video, maybe I'll show you again. I think around here, all right, it was not all lined up, but then with that, then they would line up again. Okay, and that's part A. Part B is outline the measurement that needs to be made after the radio frequency signal is turned off. As you know, it will go back to the original state, which it would emit a radio wave, and that is called the relaxation time, and you want to measure that. And in that case, it will help you to locate, to find where it is, and also find the time delay, which is the relaxation time. And in that case, you can try to find out what is the corresponding density or organ it is. For C, how the measurement provide diagnostic information to the doctor. So, well, I think that's what I just mentioned. Relaxation time give information on what kind of tissue or density of the material it is, and in that case, it can tell about the health, of course. I think the keyword is more about density of the tissue of the material by looking at the relaxation time. At the same time, you can also find the location, and that would be able to help you to construct the 3D image.